Hi, I'm Mohan. In this video, let us discuss the components of fluid power system. We know that the major components in hydraulic circuit or fluid power systems are a reservoir, pump. The function of reservoir is to store the fluid. The pump is to convert the mechanical energy into hydraulic energy. Then we'll be having the controlling valves. Again, controlling valves may be of any type. It may be directional control valves, pressure control valve, or a flow rate control valve. Okay, then we'll be having an actuator. Actuator function is to convert hydraulic energy into mechanical energy. Okay, in this video, we're going to study the controlling valve, the directional control valves. Okay, the control of hydraulic power in hydraulic power system is carried out by means of control valves. The control requirements are imposed by the function of the system. Okay, the parameters of the mechanical power delivered to the loads are managed hydraulically by controlling the direction, pressure, and flow rate. Okay, it is important to know the primary function and operations of various types of control components. Okay, then we have three types of control valves. In that, the first one is a directional control valve. As the name indicate, these valves are used to change the direction of the fluid in hydraulic circuit. And the second one is pressure control valves. These valves are used to maintain the required pressure in the hydraulic circuit. Third one is the flow control valves. These valves are used to change the flow rate of the fluid in the hydraulic circuit. Okay, in that, the first one is the directional control valve. Okay, as the name implies, directional control valves are used to control the direction of the flow in hydraulic circuit. They used to extend, retract, reciprocate the hydraulic cylinder or actuator and other components for linear motion. Okay, then again, the directional control valves are classified in a number of ways. Okay, the first classification is based on type of construction. Based of type of construction, DCVs are classified into two types. The first one is poppet valve and the second one is spool valve. Okay, poppet valve is nothing but it consists of a ball or cone mechanism. A spool valve is almost similar to piston and cylinder arrangement. Okay, the second classification is based on number of working ports. If the DCV contain two ports, then it will be called as a two-way valve. Okay, if it contain three ports, then it will be called as a three-way valve. Similarly, if DCV contain four ports, then it will be called as four-way valve. The third classification is based on number of switching position. Based on switching position, DCVs are classified into two types. The first one is two position valve. The second one is a three position valve. Okay, fourth one is based on actuating mechanism. Okay, if the DCV is actuated manually, then it will be called as a manual actuation. Okay, if DCV is actuated by means of spring or push button, then it will be called as mechanical actuation. Okay, if it uses a solenoid, that is electrical coils for actuation, then it will be called as a solenoid actuation. Okay, if the DCV uses high pressurized fluid to actuate, then it will be called as hydraulic actuation. Similarly, pneumatic actuation. Okay, in this case, the DCV is actuated by means of high pressure air. Okay, the last classification is based on control method. Based on control method, DCVs are classified into two types. The first one is a direct control DCV. The second one is indirect control DCV. Okay, next we have constructional features of poppet valve. Okay, as I said, poppet valve consists of a housing bore in which one or more suitably formed seating elements, that is movable elements in the forms of balls, cones, or position. Okay, when the operating pressure increases, the valve become more tightly seated in the design. Okay, what are the advantages of this poppet valve? The first one is no leakage. Okay, since there is no leakage, the life of the poppet valve is very more. Okay, the disadvantages includes large pressure losses due to short strokes. Okay, then we have a sliding spool. As it said, sliding spool is almost similar to cylinder and piston arrangement, but here piston, we're going to call it as a spool. Okay, the spool valve consists of a spool, which is a cylindrical member that has large diameter lands machine to slide in very close fitting a valve body. The spool valves are sealed along the clearance between the moving spool and the housing. The degree of sealing depends on the size of the gap, the viscosity of the fluid, and especially on the level of the pressure. If the viscosity of the fluid is very high, the leakage will be very more. Especially at higher pressure, that is up to 350 bar, leakage occurs to such an extent that it must be taken into account when determining the system efficiency. That is, the amount of leakage is more, especially at higher pressure operations conditions. Okay, this is one example of a poppet valve. This is called as a check valve or a 2 by 2 DCV. You can see it consists of two ports. The first one is pressure port P and actuator port A. That's why it's called as 2 by 2. The first two indicates number of ports, the second two indicates number of position. You can see the first figure, that is A. When we send the high pressure fluid through port A, that high pressure fluid pushes the ball downwards, which blocks the port P. Therefore, there is no flow. Okay, when if you are sending the fluid from port P, that high pressure fluids pushes the ball upward, which unblocks the port P. Therefore, fluid can be flow from port P to port A. Hence, this check valve is also called as a unidirectional valve. This promotes the flow in only one direction, that is P to A. The second one is a spool type check valve. Again, this is also 2 by 2 valve. The first two indicates the number of ports, pressure port and actuator port. The second two indicates number of position. Okay, you can see the first figure when the spool is at the first position. That spool block the port P. Therefore, there is no flow from port P to port A. And you can observe here the spool is actuated manually, hence it is called as a manual actuated spool valve. When the spool is actuated by distance, that spool unblocks the port P. Therefore, that high pressure fluid from the pump can easily flow from pressure port to actuator port. Okay, the next we have a three-way valve. The three is nothing but a number of ports. Here you can see there are three ports: pressure port, actuator port, and tank port. Hence the name three-way valve. And this is two-position valve. Hence the name 3 by 2 valve. And here the spool is actuated by means of push button. You can see in the when the spool is at the first position, port P is unblocked. Fluid can be flow from pressure port to actuator port. But the second spool blocks the tank port, therefore there is no flow through the tank port. When the spool is actuated, the spool blocks the port P, therefore the fluid can easily flow from actuator port to tank port. You can see the symbolic representation also. When the spool is at first position, the port P, that is port P is open, port A is open, the fluid can easily flow from port P to port A, whereas the tank port is closed. When the spool is at second position, port P is closed, that is the pressure from the actuator will be resent to the tank through the reservoir port or tank port. Okay, next we have a four-way DCV. The name four-way, it's because it consists of a four ports, pressure port P, actuator port A, and one extra port B, that is working port, and tank port. This is also two-position valve. You can see when the spool is at first position, the fluid can easily flow from port B to port T and port P to port A. That is the first square in the symbolic representation. That is, fluid can easily flow from P to A and B to T. When the spool is actuated, it changes its position. That is, at second position, the fluid is flowing from P to B and A to D. Okay, this is four-way DCV. Thank you.